Alright. So the question was for, yeah, I'm not going to load the other video because it's going to be a couple of seconds basically. But the question was to explain exercise 9 on page 161, number 3. So this is determine the equation of the tangent to y is equal to 2x minus 1 all squared plus 3 where x is equal to half. So I'm multiplying it out here so that I can apply my derivative. Okay, the derivative to the function. So we took the binomial squared and I squared it out, I got that thing. And now I'm multiplying x plus 3 out and I get 4x cubed plus 8x squared minus 11x plus 3. Okay. So remember, this is your function. So when I substitute a half, so if you're going to substitute a half into, or x equal to half into the function, we're going to simply get y equals a half times 2 minus 1 times a half plus 3. A half times 2 is 1, minus 1 is 0, so this is going to be 0 here. So the point of contact is a half and 0. Okay. Then, if you work out now dy dx, what is the first derivative of a graph? It is your gradient, your general gradient anywhere along the curve. So you apply my derivative here, I'm going to get 12x squared plus 16x minus 11. That's a general gradient anywhere along the curve. So if I substitute x is equal to half in here, then I get a gradient out at the half. So your gradient is simply going to be 12 times a half squared plus 16 times a half minus 11. 12 times a half squared is a quarter times 12 is 3 plus 16 divided by 2 is 8 minus 11. This is also 0. Not so? So if I must draw this graph, let's just put this into context. I know you guys can't draw it at this point yet. So you got minus 3 here. The graph is first going up then down. So the turning point here is off, that is why. So if you must draw a tangent to this graph at that point, the tangent is actually this graph going through here like that. Can you see that? And what is the equation? What line is this? This is also your X intercept here, not so? It's lying on the X intercept. And what's the equation of the X intercept? Y is equal to 0. I'm sure you got those values out, but you didn't know how to answer the question. But that's how you answer. Okay. Gradient was 0. You put 0 back. Into here you're going to get a half, of course. So the gradient, since the gradient is 0, is going to be parallel to the x-axis. Okay. Any problems with number 5? Yes? Determine the equation of the tangent to y is equal to x cubed minus 8 over x minus 2, where x is equal to 5. So, can I determine the equation of the tangent? So, the equation of the tangent will be in the form of y is equal to mx plus c. Can I apply, I can substitute 5 into here. And then I will get a point of contact out between the tangent and that function. Okay? So substitute 5 in, I get y is equal to 5 cubed minus 8 over 5 minus 2. What is your answer here? 81. 39. Okay, so the point of contact is 5 and 39. Okay. Then, can I apply my derivative as it stands there? No. I need to get this in the form of ax to the exponent n. Okay? So we got y is equal to, we're going to take the difference of cubes on top. So as the square, the first term is going to be x squared, that's negative, so it's positive. 2 times x is 2x, plus 4 over x minus 2. So what happens is, those cancels here, not so. So y is equal to x squared plus 2x plus 4. So that is still the function. So what do? I apply my derivative. So this is going to be dy over dx, the derivative of y with respect to x, going to be 2x plus 2. Now the gradient at x is equal to 5. Okay, the gradient at x is equal to 5 is 2 times 5 plus 2, which is 12. Okay, you all agree with that? So this now comes under here, no? It's this right here. Y is then equal to 12x plus c. So how do I calculate c? We substitute the point that's lying on this graph, which is 5 and 39. So I say 39 is equal to 12 times 5, which is 60, plus c, which implies c is going to be negative 21. Just check there. So that's the equation of the tangent. Y is equal to 12x minus 21. Let's check what's the answer then.
That's right.
Yeah, okay, now I'm feeling better about myself. Then the question says, determine the equation of the tangent. Now you see, now this one here is a bit different. Okay? So what do I need? I'm not going to need that. I'm not going to need that. Definitely will use that, I think. That's my derivative. Yes? Okay. So in 5.2, they want to know dy, dx is 3. So what do we know at this point? We know that the gradient is 3, not so? So the equation now reads y is equal to 3x plus. So in other words, we just need that point of contact. Once we got that, we got the equation of the job is done. We'll have the equation of the tangent. Not so? But what do we have? We know that the gradient is 3. dy dx is 3. Not so? But what is dy over dx also equal to? 2x plus 2. So 2x plus 2 is equal to 3. By doing this, by setting the general gradient equal to the gradient, I will find the x value at which that gradient occurs. Okay? So you will have 2x is equal to 1, so x is then equal to half. So now I got the x value at which the gradient occurs. So what do I do with that? I sub it into the original function. I can go in either one of the two. Those two gives you the same answer. Okay? So I say y is equal to 1 over 2 cubed minus 8 over 1 over 2 minus 2. Punch that in the calculator. So we got 1 over 2 cubed minus 8 over 1 over 2 minus 2. Gives you 21 over 4, is that correct? Right, so the point of contact is half and 21 over 4. Remembering, that's a x and a y. That's a point of contact between the tangent and the function. So I got 21 over 4 equals 3 times a half plus c. There's 21 over 4 minus 3 and a half. Minus 3, sorry, times a half. So your c value is going to give you 21 over 4 minus 3 times r. It's 15 over 4. Is that correct? That's 15 over 4. So therefore, y is equal to 3x plus 15 over 4. But I think the textbook would have given you an answer of 4y minus 12x equals 15. Is that the answer they gave you? Huh? Because what they do is they get rid of this fraction, man. Okay? And they write it in what they call general form of ay plus bx equals c. This is another form that's given in. But if the question says, if you explicitly say, write your answer in the form of ay plus bx equals c, then we have to multiply it up and get this answer out. But since it wasn't specified, you're going to get full marks at that point already. Okay, you guys understand? Alright. That basically brings us to the end of what I asked you for more. Huh? What? Yes. Did I give you I didn't give you exercise 10? No. We're going to draw the graph, this graph, no? Sketch cubic graphs. Did I cut this yesterday? I think I saw it earlier on. Probably deleted it by mistake. That looks so. Okay. So now we're going to look at sketch cubic graphs, and I've indicated yesterday that there's between 10 to 15 marks allocated for this section of work, okay? So it's very important to know what you're doing here. This is the example on page 167. Okay. So we're told that the cubic graph has one y-intercept, have at least one x-intercept, but at most 3 x-intercepts, may have stationary points with a local maximum and or local minimum points, may have a point of inflection where it is a stationary point or which is a point of inflection. We spoke about turning points, point of inflection, all of those things already, not so? Right, so we're considering the function f of x equals x cubed minus 5x squared minus 8x plus 12. The question says, determine and classify the stationary points. Okay. People, what are stationary points? Stationary points is our turning points. Not so? How did we work out the stationary points? How do you think we will work out the stationary points? Is the first derivative, and I said it equal to 0. Remember when we drew this graph here, we said at this point f prime x will be greater than 0, positive. From there to there, f prime x will be negative. From there onwards, f prime x will be greater than 0 again. Not so. So what happens at the turning point? The polarity swaps from negative to positive gradients. Not so. So the gradient is going to be 0. Here as well, at that turning point, your gradient, which is your first derivative, is equal to 0. And that's the reason why when they ask us to determine the stationary points, I work out my first derivative and I set it equal to 0. So do that quickly. and you solve for x. I'm going to pause the video at this point. Now we don't have much time. Okay, I'm going to go straight into it. Is it okay? So your first derivative would give us 3x squared minus 10x minus 8. Well, what do I do with that? I set it equal to 0. So we go 3, negative 10, negative 8. Gives me 4, and x value of 4, or an x value of negative 2/3. Okay. Okay, what I really need you to sketch these graphs. So we only have Wednesday and Thursday left, and you guys are not going to come to school on Friday anyway. So I'll send you a video now on curve sketching I've made during the lockdown for last year's matrics, or the year before, and you guys can go through it. But for homework for tomorrow, it's exercise 11. You're going to do for me number 1, 3, 5 and 7. Exercise 11, number 1, 3, 5 and 7. I'll send you the video to the group now. People enjoy the rest of your day. Good morning class. Good afternoon class.